You know, 3D printing has always felt like it's straight out of the future, right? It's clean, it's efficient, it's so innovative. But what if the very materials we're using are actually holding back its true green potential? Well, today we are digging into a massive breakthrough that promises both strength and sustainability in our 3D prints. Let's see how they managed to pull this off. So here's what we're going to cover. First, we'll break down the core problem. Then we'll introduce this brilliant new system, take a look at how it works, check out the test results, and finally explore what's next for this whole idea. And this really gets to the heart of it. We all tend to think of 3D printing as this super eco-friendly way to make things. But once you start looking closely at the actual materials, well, the picture gets a whole lot more complicated. And that complication is what we're calling 3D printing's green dilemma. At its core, it's this fundamental trade-off. You either get strength or you get sustainability. Okay, so here's that trade-off laid out. On one hand, you've got your high-performance filaments. These things are strong, they're durable, they're totally reliable. But they're not so great for the planet. On the other hand, you have eco-friendly filaments made from recycled or biodegradable stuff. Awesome. But they're just often weaker and their performance isn't as predictable. Until now, you basically had to pick a side. And this becomes a huge problem when you're making functional parts. Look, if you're just printing a little decorative vase, an eco-friendly filament is perfect. But what about a critical part for a machine? Something that has to bear a real load. You've been forced to choose the less sustainable, high-strength option every time. And honestly, it's been a major roadblock for greener engineering. But what if you didn't have to choose? What if you could have both? Well, some brilliant researchers at MIT and the Hasso-Plattner Institute have developed a much smarter way to print. They call it the SustainaPrint system. So, what is SustainaPrint? It's a software system that intelligently weaves together both types of filament, the strong stuff and the sustainable stuff, into a single object. It's designed to give you the best of both worlds, all without compromising the structural integrity of the part. I love how the researchers put it. They said they found a way for us to have our sustainable additive manufacturing cake and eat it too. It's not about making a compromise anymore. It's about completely reframing the problem so you can get everything you want. Now, the core idea here is so simple, but it's also kind of profound. Instead of making the entire object out of that strong, less sustainable plastic, you only reinforce the specific areas that are actually going to experience stress. The absolute best way to picture it is like a skeleton inside a body, this strong internal frame that supports a much larger but less dense structure. So how does it actually pull this off? It sounds amazing, but what's the secret sauce? Let's take a look under the hood at how the SustainaPrint process works. It's basically a four-step process. First, the software just analyzes the 3D model. Then it runs a simulation using some pretty standard engineering analysis to predict exactly where that object is most likely to bend or break under pressure. Now, step 3 is where the magic happens. It automatically figures out where to place the strong, high-performance filament to reinforce only those critical stress zones. And finally, it bundles all that information up and sends the instructions to the printer to create this new hybrid object. The real genius of the system is just how precise it is. It's almost surgical in how it applies that reinforcement, placing strength exactly where it's needed and absolutely nowhere else. And this means the vast majority of the object can still be printed with those greener, more eco-friendly materials. Okay, that all sounds fantastic in theory, but the big question is always, does it actually work in the real world? Let's see what happened when the researchers really put it to the test. So for their experiments, the team used a pretty common eco-friendly filament, Polyterra PLA, for the main body of the object. For that reinforcement skeleton, they use a high-strength material, Ultimaker's Tough PLA. And here's the number to remember. That strong material only made up 20% of the final object. Just 20%. Now, get this, with only a fifth of the object being made from that high-strength material, the final hybrid print achieved a staggering 70% of the strength of an object made entirely from the tough stuff. I mean, that is a massive, massive win for sustainability with a really minimal trade-off in performance. And here's a great way to visualize that. On the left, that's our baseline, the part made from 100% tough PLA. And on the right, you see the SustainaPrint hybrid. Sure, it's not quite at 100%, but it keeps more than enough strength for a huge range of real-world applications, all while being dramatically more sustainable. Okay, but this is where the story takes a really cool turn. In one of their tests, the hybrid object actually performed better than the one made from 100% strong material. How is that possible? Well, the researchers think that internal skeleton actually allowed stress to be distributed more evenly throughout the part, preventing the kind of sudden brittle failure you sometimes get from something that's just too stiff. It turns out sometimes smarter really is better than stronger. So, with these absolutely incredible results, what's next for this technology? Well, the future, it turns out, is going to be open and accessible to everyone. Maxine Perroni-Scharf, who was a lead author on the paper, said their real hope is for SustainaPrint to be used everywhere, from big industrial settings to local distributed manufacturing. Just imagine local workshops being able to use all sorts of recycled plastic because they have a system that can guarantee the final part will be strong enough. It's all about using less material without sacrificing function. And the team is making sure this actually gets into people's hands. It was designed for printers that can handle two materials at once, but they say it can be adapted for the much more common single-extruder setups. And most importantly, they plan to release the entire system as open source. That's going to make it a powerful tool not just for manufacturing, but for education too. Which leaves us with a final, much bigger thought. This whole idea of smart reinforcement, of using strength only where it's truly needed, it goes way beyond just 3D printing, doesn't it? From construction materials to everyday consumer products, where else could this surgical, skeletal approach help us build a world that's not just stronger, but a whole lot more sustainable too?